In OpenAI's latest blog post, there's a striking photo. At the San Francisco headquarters, in front of a glass whiteboard, an engineer wearing an OpenAI logo t-shirt is writing down a seemingly simple formula: P, text, pixels, sound. Through the glass, we can see the faint silhouette of the Golden Gate Bridge. This photo itself was generated by 4o, showcasing the realism of this technology. From the content on the whiteboard, we can infer the technical approach behind 4o. Of course, this is just an analysis based on photos, but the approach itself is interesting. OpenAI chose a counterintuitive method. Why is it counterintuitive? When generating images, it generates them one tile at a time, just like writing an article one word after another dot. Doesn't that sound strange? Remember, traditional image generation creates the entire picture at once, rather than step by step like writing. This counterintuitive method is summarized on the whiteboard as a simple process: tokens, transformer, diffusion, pixels. This process suggests that 4o may have applied text generation techniques to image generation. If this speculation is correct, it would be an interesting innovation. Let's understand this counterintuitive design dot on the whiteboard. We see a simple yet profound formula tongue sticking out: text, pixels, sound. This hints at the core idea of 4o to convert all information, whether text, images, or sound, into a unified language. It's like translating books in different languages into the same language so they can be understood and processed in the same way. Specifically, this process is like the creation of an oil painting. First, image preprocessing converts the input image into fixed-size patches, just like a painter dividing areas on a canvas. Then, the pre-trained visual encoder extracts features from each patch, just like a painter understanding what to paint in each area. Next, the transformer model predicts the next token based on the text prompt in the already generated sequence, just like a painter deciding what to paint next based on the already painted parts. Finally, image reconstruction converts the generated token sequence back into the image space, just like turning a sketch into a complete painting. This design brings two important advantages. First, just like a skilled painter ensures that every part harmonizes with the overall composition, the transformer ensures each part of the image aligns with the whole. Second, and more importantly, this approach allows 4o to simultaneously understand and process different types of information, as hinted by that formula on the whiteboard. Whether it's text descriptions, image details, or potentially future audio elements, all can be processed the same way. However, the number sequences generated by the transformer alone cannot directly become beautiful images. This is why the second stage is needed: the diffusion model. Its working principle is simple. First, add some random noise to the image, then gradually remove this noise while continuously optimizing the image quality during the process. This is like an experienced painter who can gradually refine a blurry draft into a clear artwork. The technical advantage of this combination lies in its perfect integration of the strengths of both models. The transformer is responsible for overall composition and layout, just like a painter planning the structure of the entire painting first, while diffusion focuses on the optimization of details, like an artist meticulously handling each local part. The complementarity of the two models greatly improves the generation quality. In practical applications, 4o can handle more visual elements, 10 to 20 different objects, while other systems typically only handle 5 to 8. More importantly, it can understand and integrate various types of information. In terms of security, 4o has also taken full consideration. All generated images come with C2PA metadata, allowing the tracking of the image's origin. At the same time, the system has built-in strict content filtering mechanisms, ensuring the generated content meets safety standards. For images involving real people, the system has additional restrictions in place to prevent misuse. However, 4o currently has some limitations. The generation time is relatively long, usually taking about a minute. It may be inaccurate when processing non-Latin languages, editing specific parts may affect other areas, etc. But these issues are continuously being improved. From an application perspective, the potential of 4o is enormous. It can not only be used for creative design and educational content creation, but also play an important role in fields such as game development and historical exploration. More importantly, its barrier to entry is very low. Ordinary users only need to access this technology through ChatGPT. Overall, the emergence of 4.0 image generation technology marks a new phase in AI image generation. It not only produces more realistic and precise images, but more importantly, it makes image generation simpler and more intuitive. Although there are still areas for improvement, the potential of this technology is immense. It is bringing new possibilities to the creative and design fields. As that simple formula suggests, this may just be the beginning of AI unifying various information modalities. In the future, we may witness even more astonishing breakthroughs, and all of this starts from a simple idea.